Right now, somewhere in Japan, an aircraft with no runway is quietly lifting straight into the air. No roaring jet engines, no spinning helicopter blades towering above the cabin, just a compact electric aircraft rising vertically, hovering for a moment, then flying toward the city. It looks like something from a science fiction movie, but it isn't. It's real. At the very same time, engineers from some of Japan's largest companies are building machines that could completely change how millions of people travel. Flying taxis, hybrid electric aircraft, next-generation air mobility systems, vehicles designed to fly over traffic instead of sitting inside it. And while much of the world is focused on artificial intelligence and electric cars, Japan has been quietly preparing for another transportation revolution, one that could take place above our heads. In this video, we're going to look at 5 incredible flying vehicles that are already being tested, already flying, or moving rapidly toward commercial service. Then, we're going to look at one Japanese engine that proves this revolution isn't happening only in the sky, because by the end of this video, you'll understand why many engineers believe Japan could once again reshape the future of transportation. Let's begin. Number 5. SkyDrive SD-05. If there is one aircraft that represents Japan's vision of urban flight, this is it. The SkyDrive SD-05 doesn't look like a helicopter. It doesn't look like a conventional airplane. Instead, it looks like an entirely new category of aircraft. 12 electric rotors surround a compact passenger cabin. The aircraft rises vertically from almost any suitable landing area. No runway, no long takeoff roll, no airport in the traditional sense. Just lift, hover, and forward flight. The SD-05 is designed to carry one pilot and 2 passengers at speeds of around 100 kilometers per hour. Its mission isn't replacing commercial airlines, it's replacing traffic. Imagine arriving at Kansai International Airport. Instead of spending an hour inside buses, trains, or traffic jams, you board a small electric aircraft waiting just outside the terminal. Minutes later, you're landing in downtown Osaka. That is exactly the future SkyDrive wants to build. Every second during flight, onboard computers monitor the aircraft's balance, battery condition, wind direction, motor output, and dozens of other variables. Instead of one large engine, the aircraft relies on multiple independent electric motors working together. If one motor loses performance, the flight control computer instantly compensates using the others. That level of redundancy is one reason many engineers believe electric aircraft may eventually become safer than people expect. But perhaps the most remarkable thing about SkyDrive isn't the aircraft itself. It's that Japan isn't treating it like a futuristic concept. The company is already working through one of the world's toughest aviation certification processes, preparing the aircraft for real commercial operations. Because in Japan, flying cars aren't being built as toys, they're being built as public transportation. But before the SD-05 became Japan's flagship flying vehicle, another aircraft had to prove that the impossible was actually possible. Number 4. SkyDrive SD-03. Long before Japan began talking about flying taxis for everyday passengers, there was a much smaller aircraft that had only one job: prove that it could actually fly. That aircraft was the SkyDrive SD-03. Compared to today's designs, it looks surprisingly compact, almost fragile. But don't let its size fool you. The SD-03 became one of Japan's first successful crewed eVTOL aircraft. When it completed its public demonstration flight, the goal wasn't speed, it wasn't range, and it certainly wasn't luxury. The mission was much more important: to prove that vertical electric flight could be stable, controlled, and repeatable. As the aircraft slowly lifted from the ground, dozens of onboard computers constantly monitored altitude, balance, wind conditions, battery output, and motor performance. Instead of relying on one large engine, every electric rotor worked together as part of a single intelligent flight system. If one motor produced slightly less thrust, the others immediately compensated. The pilot wasn't controlling every movement. The aircraft was making thousands of tiny corrections every second. That demonstration changed everything. It showed investors, manufacturers, and government regulators that Japan was serious about urban air mobility. Without the SD-03, There would likely be no SD-05, no commercial certification program, and no serious discussion about building flying taxi networks across Japanese cities. Sometimes the most important aircraft isn't the fastest one, it's the one that proves the impossible can actually work. And once SkyDrive proved electric vertical flight was possible, Japan's largest engineering companies began asking a much bigger question. What if these aircraft could fly much farther? Number 3. Honda's hybrid eVTOL. Most electric flying vehicles face the same limitation: batteries. The farther you want to fly, the more batteries you need. But adding batteries also adds weight. More weight means more energy. More energy requires even larger batteries. It quickly becomes a vicious cycle. Honda decided to solve the problem differently. Instead of depending entirely on batteries, the company is developing a hybrid electric aircraft. A compact gas turbine generates electricity, while electric motors power the aircraft's propellers. That simple idea could dramatically increase range. Instead of flying only across a downtown area, Honda wants its aircraft to connect entire cities. Imagine leaving Osaka and landing in Kyoto without ever touching a highway. No traffic jams, no railway schedules, no conventional airport. The aircraft rises vertically like a helicopter. Then, once it reaches cruising altitude, it transitions into wing-borne flight, allowing it to travel much more efficiently. Honda has already completed the first successful flight of its full-scale technology demonstrator. The flight lasted only a short time, but aviation history has shown that the first successful flight is often the hardest milestone. Everything after that becomes engineering refinement: longer flights, higher speeds, greater efficiency, better safety. That philosophy has guided Honda for decades. The company rarely rushes revolutionary technology. Instead, it improves it until people trust it. And while Honda is trying to solve the challenge of longer-distance electric flight, another Japanese company believes the biggest challenge isn't flying at all. It's building thousands of aircraft instead of just one. Number 2. Toyota and Joby Aviation. At first glance, this doesn't even look like a Japanese flying vehicle. The aircraft itself was designed by Joby Aviation in California. But behind nearly every major step toward large-scale production stands one of Japan's biggest engineering companies, Toyota. Instead of trying to build its own flying taxi from the ground up, Toyota made a different decision. It invested hundreds of millions of dollars into Joby and began sharing something even more valuable than money: decades of manufacturing experience. That may not sound exciting until you realize that building one prototype is relatively easy. Building thousands of aircraft that perform exactly the same way is one of the hardest challenges in engineering. Toyota has spent more than 70 years perfecting that process. Its engineers are helping improve production methods, manufacturing quality, assembly efficiency, and reliability. Because the future of flying vehicles will not be decided by whichever company builds the first prototype. It will be decided by the company that can safely build thousands of them. The Joby aircraft carries 1 pilot and 4 passengers. 6 large electric propellers lift it vertically from the ground. Once airborne, those propellers tilt forward, allowing the wings to produce lift just like a conventional airplane. That simple transition is one of the reasons the aircraft can travel much farther than many smaller eVTOL designs. Instead of spending the entire flight hovering like a helicopter, it quickly becomes an efficient airplane. Joby expects the aircraft to cruise at speeds approaching 200 miles per hour, while producing only a fraction of the noise generated by conventional helicopters. That could completely change transportation around major cities. A 90-minute drive could become a 20-minute flight. No traffic, no highways, just direct transportation through the sky. Toyota believes this technology deserves the same reliability people already expect from their cars, because nobody will trust flying taxis unless they are dependable every single day. And Toyota has spent decades proving that reliability can become one of the most valuable technologies of all. But Japan's flying ambitions don't stop there. Another company with decades of aerospace experience is quietly preparing its own vision of the future. Number 1. Subaru Air Mobility Concept. Most people know Subaru for building reliable all-wheel drive cars. Few realize that the company has also spent decades designing aircraft. Long before Subaru became famous for the WRX or the Outback, its parent company was manufacturing airplanes and helicopters for Japan's aerospace industry. Today, that experience is helping shape Subaru's vision of future urban aviation. Together with Toyota, Subaru has been developing next-generation electric vertical takeoff and landing technology. Unlike some futuristic concepts that focus mainly on appearance, Subaru is concentrating on something much more important: safety, stability, and predictability. The company's engineers believe future passengers will only accept flying vehicles if every flight feels calm, smooth, and completely routine. In aviation, boring is actually a compliment. Passengers don't want surprises. They want every takeoff, every landing, and every journey to feel exactly the same. That philosophy perfectly reflects Japanese engineering. Don't simply build something impressive. Build something people can trust with their lives. Subaru's aerospace background gives the company decades of experience working with lightweight structures, flight systems, and aircraft engineering. Now those lessons are being applied to a completely new generation of electric aircraft. And when you step back and look at all 5 flying vehicles we've explored, something remarkable begins to appear. These companies aren't competing to build one spectacular machine. They're building an entirely new transportation ecosystem. Some focus on urban flights. Some focus on longer regional travel. Others focus on manufacturing. Together, they represent Japan's biggest aviation transformation in decades. But perhaps the most impressive Japanese engineering breakthrough isn't flying above our heads at all. It's already driving on roads around the world. And it may be just as revolutionary as every aircraft we've seen today. Now, let's come back to the ground. Because while Japan's flying vehicles may represent the future, one Japanese engineering breakthrough has already changed transportation for millions of people around the world: the hybrid engine. When Toyota introduced the first Prius in 1997, many people believed hybrid cars would never become mainstream. They were too expensive, too complicated, too different. Today, millions of hybrid vehicles are driving on roads across the globe, and Toyota never stopped improving the technology. Its latest 5th-generation hybrid system represents more than 25 years of continuous engineering development. At the heart of the system is a highly efficient gasoline engine, working together with powerful electric motors, intelligent software, and a battery that constantly exchanges energy during every journey. Unlike a traditional car, the hybrid system is always making decisions. Should the vehicle use electricity? Should it combine both power sources? Should it recharge the battery while braking? Should it shut the gasoline engine off completely? Hundreds of calculations happen every second without the driver ever noticing. The result is extraordinary efficiency. Some of Toyota's newest hybrid models can travel well over 1,000 kilometers on a single tank of fuel. For many owners, that means visiting a gas station only once every several weeks. But perhaps the most impressive achievement is something most drivers never think about: thermal efficiency. Every combustion engine wastes energy. A large portion of the fuel simply becomes heat instead of motion. For more than a century, engineers around the world have tried to reduce those losses. Toyota pushed its newest hybrid engines beyond 40% thermal efficiency. That number may not sound dramatic. In engineering, it is. Improving thermal efficiency by even 1% requires years of research, new materials, redesigned combustion chambers, improved fuel injection, better cooling systems, and countless hours of testing. Toyota achieved it through thousands of small improvements rather than one revolutionary invention. That approach has a name in Japan: continuous improvement. Instead of chasing spectacular breakthroughs every few years, Japanese engineers often improve existing technology little by little until one day it quietly becomes the world's new standard. That philosophy appears everywhere. The Shinkansen wasn't successful simply because it was fast. It became legendary because it remained reliable year after year. Japanese cameras became famous because photographers trusted them. Japanese manufacturing became respected because factories produced the same quality every single day. And now, the exact same philosophy is shaping the future of aviation. Think back to every aircraft we've explored today. SkyDrive is developing practical flying taxis for urban transportation. Its goal isn't building the fastest aircraft in the world, it's building one that people will trust enough to use every day. Honda isn't trying to build the biggest flying vehicle, it is solving one of aviation's hardest problems: range. By combining electric propulsion with a hybrid power system, the company hopes to connect cities rather than simply neighborhoods. Toyota isn't focusing only on aircraft, it is focusing on manufacturing, because history has shown that a revolutionary machine changes very little if only a handful of people can ever use it. Subaru brings decades of aerospace engineering into the next generation of electric flight, concentrating on stability and safety before spectacle. Each company is solving a different piece of the same puzzle. One develops aircraft, another develops propulsion, another perfects manufacturing, another focuses on reliability. Together, they are creating something much larger than 5 individual flying vehicles. They are building an ecosystem, and perhaps that is Japan's greatest strength. The country rarely tries to impress the world with one enormous announcement. Instead, it quietly improves hundreds of different technologies until they all begin working together. That is exactly how Japan transformed the automotive industry, exactly how it transformed high-speed rail, exactly how it became one of the world's most respected manufacturing nations, and it may be exactly how it transforms urban aviation over the next decade. The biggest surprise isn't that these flying vehicles already exist, it's that most people outside Japan have never heard of them. While much of the world debates what transportation might look like 20 years from now, Japanese engineers are already testing it, already certifying it, already preparing factories to build it. Will flying vehicles replace cars completely? Probably not. Will they replace commercial airlines? Almost certainly not. But could they eliminate traffic for millions of people living in the world's busiest metropolitan areas? That future no longer feels impossible. It feels much closer than most of us realize. Perhaps one day, booking a flight across your city will feel just as ordinary as calling a taxi. And when that happens, don't be surprised if many of the technologies making it possible were developed in Japan. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications. We explore the technologies, engineering breakthroughs, and innovations quietly shaping tomorrow's world before they become everyday life. Now I'd love to hear your opinion. Which Japanese innovation impressed you the most? Was it SkyDrive's flying taxi, Honda's hybrid aircraft, Toyota's manufacturing revolution, Subaru's aerospace engineering, or Toyota's incredible hybrid engine? Let us know in the comments, because the future isn't waiting, it's already taking off.